Hello, my name is Dino Vieland, and today I'll be giving you a demo of Python tools for Visual Studio 2.0 running on Visual Studio 2013. With Visual Studio 2013, we've made it really easy to get started coding in Python. I'll start here, File, New Project, and this is the normal New Project dialog that you're used to inside of Visual Studio. But if I go under Other Languages, you'll see that there's now a Python entry that I can click on, and I have Get Python Tools for Visual Studio. I'll click OK. And inside of Visual Studio, we'll open a download link. I can just click on that, and that's going to go off and download Python tools for Visual Studio from the web, and I'll be able to install it right here. The download's completed. I'll click on Run. We'll go ahead and launch the installer. Click Install. Visual Studio needs to shut down to complete the install. It'll be restarted once the install is done. So the installer is completed. I'll click Finish, and Visual Studio will restart. Now I'm back in Visual Studio, and I can go ahead and File, New Project, Python, and I have a bunch of different choices to choose from. So let's go ahead and start with a normal Python application. And we've got a simple Hello World program, and you can see we've got a project over on the right-hand side in Solution Explorer. So one of the first things you might want to try out is actually running some Python code. So I'm just going to go ahead and set a breakpoint here on this first line, and I'll press Start, which will launch my program, except for it doesn't because I don't actually have a Python interpreter installed. So I'll just go ahead and click Download and Install Python, Run. We'll run that installer. It'll go ahead and do its thing, copying all of the Python files and the interpreter and installing that, and it's done. So I click Finish, and I'm back to Visual Studio. New in PTVS 2.0, we have a interpreters window, which I can bring up here, and it'll show me the status of my current interpreter. Right now the completion database is all up to date. That's because I've let it run for a little while, and I can bring up an interactive window right from here, which will let me type some code. Or I can bring up various interpreter options, refresh the database if I've installed some new things, or whatever I want. This will give you a nice dashboard view of all the different interpreters that you have installed. I'll go ahead and dismiss that, and let's take a look at some of the IntelliSense features. So we've made a bunch of improvements to the IntelliSense in PTVS 2.0. If you've used PTVS before, you're already used to the great IntelliSense that we give you. We model your code very thoroughly, we understand classes, functions, how data flows through your program, and our analysis gives you nice results that let you quickly get to completion, signature help, and so on. But we've improved it even more in PTVS 2.0. So first, let's look at the actual editing experience of using completions in PTVS 2.0. If I type import and then space, I get a list of completions of possible modules which I can import. This isn't anything new, we've had this all along, but we have a new filtering experience for whenever you're using completions. So here I can type AG, and we'll filter down to all of the things that contain an A and a G. This is actually a pretty intelligent algorithm that you can play around with and see the different results, but we try to let you give us the minimum amount of information to get to your targeted completions. So if you only know part of a name or some substring that's contained within the string, you can input that, and you'll see that in your completion list, and then you can just hit tab and it completes. But we've also made some improvements to the core analysis engine in PTVS 2.0. If you've used PTVS before, you're already used to our great completions and analysis. So for example, if I have a simple class like this, where I'm assigning a value into an attribute, and I go ahead and create an instance of that class, we'll understand that that class has the attribute value, and I can dot through that, and we understand that it has the members from the integer type. I can go ahead and change my code, and we'll reflect those changes in real time, so I can dot through here again, and we know it's a string. And I can even pass in multiple values, and if we dot through, we'll see that we give you members for both integer and string types here, and we tell you which one they're coming from. None of that's changed. But there are other areas where we've actually improved the code analysis so that you get better, more thorough results. So one example of that is with decorators. So here I'm going to go ahead and define a function that I'm going to use as a decorator. It's going to have an inner function, which is going to just do some addition, and it's going to go ahead and return that inner function, and I will go ahead and decorate a method here that returns a constant value. And now I can go in, I can call this and pass in an integer value, and we understand that's what's going to come back out of that is an integer. On the other hand, if I come in and pass in a floating point value, we'll see that we understand that there's effectively two adders in the world, one whose type we don't understand, and one who takes an int. I'm going to add the one here that is going to have a float, and you can see if I hover on A, I see an integer. If I hover on B, I see a float value. If I try calling C again, we now understand there are different versions of this, int, float, and we're keeping those all independent because as you go down different code paths, you're only going to see a certain set of types. And so rather than thinking that A or B might be an int or a float, we're being really precise and understanding exactly what's going to happen here. Meanwhile, if I go into adder, I can see that it's getting past both float and integer types. So from that perspective, I can understand what my functions are being called with. We've also improved the code navigation features in Python tools for Visual Studio 2.0. Of course, all the existing ones that you're used to are already there. So here's a larger library called Beautiful Soup, and I can come into it and look around, and let's say I wanted to understand the setup function and who's using it. I can right-click on it, find all references, and you can see there's one caller to it. I can quickly navigate to that caller. Likewise, if I was at the call site here and I wanted to see the actual definition, I can right-click on the method call and click Go to Definition. We have a pretty good analysis of functions as well. So here I'm in a find one function, and it's actually getting this method that's passed into it. And if I do find all references on that, you can see that I get not only the declaration of the parameter, I get the call to the method, but I also see all of the individual functions that are being passed in from different call sites. But also in PTVS 2.0, we have the new Navigate To feature. So I can come in and hit Control comma, which brings up the Navigate To dialog. This is in line in Visual Studio 2013. And I can come in here and type in a subphrase which will be searched for. And so here we can see I typed in soup, and we get a bunch of different soup classes which are defined in my Beautiful Soup module. I can search for anything in here that I like using substrings, and it'll quickly bring me to relevant places in my code. I can also click on the entry, and as you can see, I go to the definition. Another new feature in 2.0 is the reformat code command. So I can now go to Edit, Advanced, Format Document, and as you can see by the change markers here, my code has just been reformatted. If I were to undo that, you can see a little easier what actually happened. And you can see that we just inserted some spaces where there weren't any between some binary operators. So I can control many options here via Tools, Text Editor, Python, Formatting, where we have lots of different options around the spacing that occurs in your code, how statements and how things are wrapped. These, by default, try to follow PEP 8 as close as possible. We've also made a number of improvements to debugging in PTVS 2.0, including Debug as Script, Remote Debugging, and Mixed Mode Debugging. For Debug as Script, I can click on any script that I have open in the editor and just select Debug as Script, and that'll go ahead and launch the script under the debugger. This doesn't have to be a script that's in my project. It can be any old Python file that I've opened up, and it just lets me quickly debug without changing project state or even necessarily working with a project. We also now have the ability to attach to a remote process running on another machine. So I can go to Debug, Attach to Process, and you'll see we now have these two new transports. One uses SSL for encrypting the content that's going across the wire, and one's unsecured and is suitable for running on an intranet. I'm going to go ahead and use the unsecured version because I'm running on the intranet. I just need to enter in a secret password that I've established in the program that's running, and I need to give it my machine name and the port number to connect to. So I'll go ahead and do that and click enter. It'll go ahead and attempt to make the connection, and we can see we're running CPython on Windows on a 32-bit machine. This will connect to a machine running Linux, OS X. All it needs is the TCP port, so it'll work anywhere. I'll go ahead and click attach, and let's go ahead and break into my program. So here I've opened the file before, so Visual Studio happens to know where to find it. If not, I might have to navigate to a share where it's available. But from here I can go ahead, I can start stepping through my program, and you can see it's just a real simple program. I can inspect state, I can evaluate values in the watch window. I can even go over to our debug REPL window and I can start importing modules, so import OS. I can do os.environ, and that's going to give me a bunch of results, and one of those is even going to be my computer name. So I can see that that's running on Dino V, and I can switch here, and you can see that I'm running on a different computer over here. So we have debugging across the network. Another new feature for debugging is mixed mode debugging. This allows you to debug both a C++ application as well as a Python application at the same time. You'll see a mixed call stack. You'll be able to step in and step out from either C++ to Python or vice versa, and you can inspect the state of both C objects as well as Python objects. So here I have a solution that has a Python application and a C++ extension module. If you've written an extension module before, this should look pretty familiar. It's all pretty boilerplate code. And I'm just going to go ahead and launch my Python application, and I have this breakpoint set here. So we'll launch, and we hit the breakpoint. Now, the first thing that you should notice is that we have a call stack over here that includes both my Python location as well as C location. So I can double click on this. I have symbols for Python loaded. It's actually required for mixed mode debugging. If I had the source code for Python itself, I could browse and look at that portion of the stack. So what I'm going to do from here is just go ahead and step in, and you can see that did a step from Python to Python, and my call stack now reflects that I have a module and that's calling into Python. Let's go ahead and continue stepping, and we'll step over, and we're going to step in here, and you can see at this point I've now stepped from Python into my C++ code. And so my stack again reflects that. So I have my Python call stack, and then I have a Python to native transition, and now I'm in my C++ code. Let's go ahead and continue stepping in, and you can see now I'm back over into the Python side of the world, and again my call stack's reflecting both the native and the Python call stack. While I'm in the Python side of the world, I can look at values. I can come in here and expand things, and I'll see the various objects. I can even go over to the watch window, and I can evaluate arbitrary expressions. And that works just fine. When I'm in the native side of the world, I can do C expression evaluation, but not Python expression evaluation. Finally, let's flip over to my test module here and find the frob method that we're about to call. And I'm going to go ahead and set a breakpoint there and continue execution. And you can see we are calling on this native object. So that's the new mixed mode debugging feature. You can enable this on your projects by going to the project properties and going to the debug page and clicking enable native debugging. Another major new feature that we've added in PTVS 2.0 is unit test support. This feature uses Python's built-in unit test module, which is commonly used for writing test cases, and lets you run the test from within Visual Studio, see the results, and analyze them. So here you can see I have Test Explorer open, and it's already discovered the tests that are inside of my project. I would like to run those tests, so I'm just going to click Run All here, and it's going to run everything. They'll run one after another, and as each test completes, it'll go ahead and populate the results here in Test Explorer. So you can see, not surprisingly, that one test failed and one test passed. I'd like to dig into that failure a little bit more, so I'm going to go ahead, right-click, and choose Debug Selected Test. I'll go ahead, launch into the debugger, and you can see I hit my breakpoint and I could quickly step through, investigate, and see what's going wrong. Another tool that Python Tools for Visual Studio comes with is the integrated profiling support. This lets you quickly drill into where hotspots are inside of your program. Here I have a project set up that has the PyStone benchmark in it, and I'll just go ahead and kick off profiling here. I go to Analyze, Launch Python Profiling, and by default I can choose either to profile my project or an individual script. I'm just going to go ahead and launch the project here. Click Start. The program will run. The performance information is calculated, and at the end we show you the performance report. Here I can click on individual functions and drill into what's going on. You can see that I get a view of who's calling it, what the current function is doing, and what the current function is calling. And I also get a nice source view below. I can also switch views to caller callee. This is kind of a nice view in that I can see all of the numeric data very easily in a table. We've also made a number of improvements to the project system in 2.0. These include virtual env support, show all files, and a number of performance and bug fixes. So to demonstrate some of these, I'm going to use a Django application. So I'll do File, New Project, and create a new Django application. Now in Solution Explorer below the project, you'll notice that we now have a Python environments node. I can right-click on that, and you'll see a number of options. I can add or remove Python interpreters, add a virtual environment, or add an existing virtual environment. Today I'm going to add a virtual environment which is going to create a new one. I can give the name and I can choose the base interpreter I want to add it from. So I'm going to go with 2.7, and you can see we're going to do a number of actions here, including installing pip and virtual env because I don't have those installed yet, and installing the virtual env package, and then going ahead and creating the virtual environment. So I'll click Create. And you can see in the output window that I get some status about what's going on here. So you can see my virtual environment has finished creating, and it's now populated below the Python Environments tab. It's also in bold, indicating that's the current active Python environment. The next thing I'm going to go ahead and do is install a package into it, and that's going to be Django. So I right-click, Install Python Package, and I go ahead and choose Django here. Press OK, and you can see again in the output window that will show you the progress as we go off and download and install Django. You can see in the output window that Django is now installed successfully, and if I come up to my environment here, we can also see that Django is available in the list of installed packages there. So at this point, I'm just going to go ahead and launch my app, which is going to, of course, run against the activated virtual environment where I now have Django installed. So you can see my app's starting. Django is doing its normal validation on startup. And we open the web browser to the Welcome to Django page. One of our most popular requests for 2.0 was the Show All Files feature. So now that I have an environment created, that actually got created below my project. And so if I wanted to look at those files, I could click on Show All Files here, and you can see that we have the env folder, and we have the library, and all of the typical files that you'd expect to be in your virtual environment. If I wanted to bring those into my project, I could right-click on them and choose Include in Project, and now that file is included inside of my project. I can move it back out of my project by right-clicking and choose Exclude from Project. So this lets you quickly navigate the file system from within Visual Studio and add files to your project. This is great for web projects where you frequently have some files that are not part of your project but are maintained on disk that you might want to interact and edit. One final new feature we introduced in this release is the ability to deploy to Windows Azure websites. So I've created my Django application now, I've created the virtual environment inside of it, and installed the version of Django I want to run against. So now I'm just going to simply right-click on my project and choose Publish. This will bring up the Publish Web dialog where I can import my Publish profile, which I've previously downloaded from the Windows Azure portal website. So I'm going to go ahead and browse and find my Publish settings, click OK. And this is going to read all the settings out of that file. I can just click Publish here, and we'll go ahead and start deploying the application to Windows Azure. You can see now that the publish is completed and that my website is now actually running in the cloud over on ptvsdemo2.azurewebsites.net. So it's as easy as that to go ahead and create a Django application and get it running in the cloud. So that's an overview of Python tools for Visual Studio 2.0. I hope you found it informative, and if you'd like to know more about individual features, check out the other videos and documentation. Thanks for watching.